Thank you for joining this lesson. We're going to discuss mathematics paper 2, longitudes and latitudes. An airplane leaves town A, 83 degrees north, 155 degrees west, to town B, 40 degrees north, 25 degrees east, using the shortest route at a speed of 450 knots. Take pi as 22 out of 7 and radius of the earth, capital R, is 6,370 kilometers. Part A, Roman 1, calculates the distance between A and B in nautical miles. Remember to subscribe to this channel and to also share the link with your friends. The number attached here can be used to organize for individualized tuitions if you are interested. It can also be used to request for learning materials in mathematics and physics. Let us look at the solution of this question. I encourage my students to, first of all, begin by sketching the location of these places on the Earth's surface. So on my right hand side of the working space, I'll come up with a simple sketch of how the places have been placed on the Earth's surface. So assuming this is the sphere of the Earth, then we will have 0 degrees equator. We will also have 0 degrees prime meridian. Now, any other longitude and latitude can be mentioned with reference to this main latitude and longitude respectively. Now we are talking of 80 degrees in the north, 83 degrees north, that is where A is found, and 155 degrees in the west. So 155 degrees in the west. This is 155 degrees in the west. Then we have another town called B, 40 degrees in the north. So still on the northern hemisphere, 40 degrees north, and 25 in the east. So on the east side now of the prime meridian, 25 degrees in the east. This is where we have our town B. So we have B there, and we have town A at this point. So town A is at this point, the intersection of 83 north, 155 west. B is on the intersection of 40 degrees in the north, 25 degrees in the east. So those are the two places. Now we are talking about the distance between them in nautical miles. Remember, this plane is using the shortest route possible. It's good to know that the shortest route between two places which are on what we call supplementary longitudes is the distance through the poles. So if the places are on the northern hemisphere, then the shortest distance will be the distance across the North Pole. If they were on the southern hemisphere, then the shortest distance would have been the distance across the southern hemisphere. So for this case, we're going to trace the distance from A through the North Pole, then down to B. It's good to know that when we are following a great circle or the poles, we usually take this one as the, let's say this is our equator, 0 degrees equator. Now for us to locate the latitude of A, we are measuring from the axis of the earth 83 degrees. So we are measuring 83 degrees. 83 degrees to the north. But to locate the other place, which is B, we are only measuring 40 degrees still to the north. 40 degrees to the north. Therefore, we should know that because the route here is 25 in the east, the longitude here is 155 in the west, then it should be known that once the plane reaches at the North Pole and it was following longitude 155 in the west, then it continues with the same route. It will find itself automatically flowing along 25 in the east. So if a plane is moving through 155 in the west, then upon reaching the North Pole, it just proceeds with the same path. It automatically assumes the route 25 degrees in the east. So that is how supplementary longitudes behave. And now we are saying the path now followed from this point to this point will be distance along a great circle, radius being the radius of the earth, and now the angle at the center of this arc of this path is going to be, when we take 180 and we subtract 83 and 40, this gives us exactly 57 degrees. Therefore now, it is distance along a great circle in nautical miles. In this case, the distance will be given as 60, which is a constant, multiplied by theta, which is the angle at the center of the arc or the path. Now we need 60 times 57, and this will exactly give us 3420 nautical miles, which is now the distance. We have a part 2, whereby we are told to calculate the time taken to travel from A to B. Now from A to B, we should know that time is usually given by distance out of speed. The distance is already in nautical miles and the speed is in knots. The speed has been given as 450 knots. Now knots is speed in nautical miles per hour. When distance is in nautical miles and time in hours, speed is calculated in what we call knots. Therefore, we can now get our time in hours, which is 7.6 hours. That is still okay, but we can convert the fraction, which is 0.6 of an hour, and that will be 36 minutes. That will be 36 minutes. Part B, we are told that from B, the plane flies westwards along the latitude to town C, 40 degrees in the north, 13 in the west. Calculate the distance BC in kilometers. Therefore now from B, the plane moves westwards, which means now to the left, until 13 degrees. So this is where C is 13 in the west. So the plane now is moving along the parallel latitude, or the parallel of latitude. That means the plane is moving along a small circle. Along a small circle, distances in kilometers have a formula, and we get such a distance in kilometers along a small circle, or along the circle of a latitude, using we can say an angle alpha divided by 360 2 pi r cosine of the latitude. This is when distance is along or across a latitude. So now theta is the longitude difference. Moving along the same longitude way to 13